So procedural generation and infinite worlds have been around for quite a time. It's an algorithm that has led to the generation of some of the most awesome game worlds out there. Not only are these worlds different every time we play them, but they can be so vast that even a lifetime is not enough to check out every corner of the world we play in. But even 2D games like Terraria or 2.5D games like Hades use these algorithms to generate a new environment for the player to explore. But how are developers able to use these algorithms to generate random worlds to their needs? It basically comes down to knowing how to feed the algorithm with the right set of rules. And today we are going to find out that the individual steps to making these rules are not as complicated as you might think. So let's have a look into procedural generation and make our own little infinite world. So we need to start off with something weird, but actually really important, and that is the triangle. And no, I don't mean it that way. Triangles are actually used by the graphics card to render everything. Every video game that you've been playing has been rendered in triangles. Of course you cannot see it. I mean, you can see it in the old Mario games or any other old game, but nowadays the triangles are so small that you don't see the blockiness. Yeah, of course you had to look at Minecraft for the example. So knowing that we are supposed to follow, to create triangles, we actually can dive into some really cool things regarding game engines, because they can draw the triangles for us if we just give them the points. This makes our job super easy, because if we place the points well, the game engine will handle the rest of the creation. Damn. So we can start by putting a lot of points in a perfect grid, just for testing purposes. And when the game engine connects all of the points, we have a perfect plane. So I also made myself a little player character, and we can now run around as a little bean. It's still a bit boring, of course, but the cool thing is that we can now set the height for each individual point and create something that looks a little bit more interesting. It's of course just a weird shape, but we can at least run around on it, and yeah, that's really all we can do. We are also about to dive into something really epic, so can I get some epic music, please? Okay, so we are now very close to being able to generate any type of terrain that we want to create. All we really need to do now is set the right height for each individual point. The difficult thing about this is that we cannot set the height randomly. If we were to do that, then the points would be super weird, and we have something similar to this weird creation that we had before. What we need to do is create a smooth transition between the points. And this is exactly why it's called procedural generation. If we had to calculate this from scratch, it would actually be kind of difficult. But luckily for us, there is some really smart people that created some weird ass algorithms that we can now just use in today's game engines with just one line of code. It gives us this weird thing called noise map. It looks super funky, and it's just values that are from white to black with different scales of gray. But the cool thing about it is that computers see white and black as values that go from 0 to 1. So we can use this to set the height of each individual point, and we suddenly get something that looks really cool. Remember how I could do this before with the noise map? Well, now I can do the same with the terrain. Okay, I'm sorry. We can also assign a different color for each individual gray tone, and we get something that looks a little bit like a map. If we now combine both of these together, we get a really cool looking result that already looks kind of like a good game world. Knowing this, we are really close to becoming professional game developers that get paid a lot of money just to create this algorithm. Not really, that's a lie. But we can use this to make something even better. Right now, it still looks a little bit pixelated. That is because we used our noise map to set the color. As you can see, the noise map is not as detailed, so it's good to use it for the height, but if we use it for the color, it gets this pixel edge. There is two ways to how we can now make this actually look very good. First, we are gonna use the height of the terrain to set the color. Of course, this will look a little bit too cartoony with these perfect lines, so it's nice if we introduce a little bit of fade. And to spice it up a little bit, we can add a texture for each different area as well. So we have a sandy texture for the bottom areas, a grassy texture for the main land, and more of a rocky texture for the mountains. But how can we now make this look even better? The second way to add some more spice is by adding detail, like grass, trees, and even water. The water looks fancy, but it really is just a flat plane, colored blue, a little bit transparent, and a loop scrolling over a texture that looks like waves. We can also pick random positions for the grass and trees so that it always will be a little bit different, but we can also change the seed in general for our world because it will change up our noise map and therefore lets the environment look different every time. All of this is the basis for our infinite world, and we will only need to plug all the pieces together. But before that, let's actually have a look at how we can just change the colors of our environment, and instead of grass and trees, spawn cacti, and we suddenly have a totally different biome. So it really comes down to our imagination to what type of world we want to create. Also, don't forget to subscribe because it would help me out a lot. Okay, so now let's make this a proper game where we actually have a world and not just a piece of our land that we created. However, we want our world to be infinite in size. But imagine for our computer to render something that's infinite, that would take kind of long. So what video games actually do is only render the area around the player. This way the computer can save up space because it doesn't need to render and process the whole world at once, but only the chunks around the player. If we look from the top, it looks like this, and we will only render as far as the player can see so that he doesn't notice that part of the world is cut off, but we still save a lot of resources. Video game developers actually need to take care in this process because we usually calculate the world in the background, meaning that when we pull it to the main process of our game, it can fuck up a little bit and look really weird. But I mean, that was super easy to fix, didn't take me like hours to notice what I was doing wrong when I did that. Yeah. So when we spawn the pieces around the player, they obviously cannot be exactly the same. So when we look at the noise map of each piece, the noise map of the next piece has to be scrolled in the next direction by the amount of distance between the pieces. Thereby, the noise maps actually line up perfectly, and when we use that to set the height for our terrain, we have a world that lines up and actually looks pretty cool. And finally, we can render pieces that are further away with less triangles, because the player cannot see that something that is further away is not as detailed. In the game engine, when we look from the top, we can see that the areas that are closer to the player are much darker because there's a much higher density in triangles. Pieces that are further away have much less triangles, which saves us a lot of processing power, and therefore the player has a way higher FPS rate. The only problem is that when we have pieces that are next to each other that are not the same resolution, they kind of create some weird edges. That kind of makes sense because a piece that has more points can follow a certain line smoother, whereas another piece has less points between this line and will have more edges, and therefore they don't line up perfectly. We can fix this by creating a high resolution border around each piece. This way, it does not matter what resolution the piece has inside, because every piece will always have the same border resolution, and therefore they will fit together. The only problem is that now we have the same issue within a piece, but that's okay because as long as we are within the piece, we know where the points are, and so we can connect them and fix the gaps. Inside the game, when we now run around, we can leave the player where he stands and move the camera into the distance. We can see that these pieces line up really nice now, and I really think it kind of looks like a tailor when he stitches together different pieces of cloth. It's really cool to see and honestly kind of satisfying to be able to play around with this. I kind of feel like a god when I'm doing this simulation. I don't know, is that weird or not? So it's finally time to check out our world, but maybe not as a bean. I decided to make a player character for that looks a little bit better. And also I added a sky, which looks much nicer, and we have even some birds chirping in the background, and I think it adds to this whole experience quite a lot. It's obviously not perfect and there's much that I can still add. Obviously we don't even have animals in this world yet, which would be cool, but that's maybe for a future project. If you like this video, then please subscribe, and here's a suggestion for other cool game development videos.